And hello, everybody. Welcome to the Land Tamer stream, day 430. Yes, 430. And we're doing this thing here. More WRED clarification. Weighted random early detection. So I hope you're having a good Monday. I certainly am, and it's been an interesting day. I don't know if anybody here is a Game of Thrones fan. I've been certainly talking to people about that. It's been fun. Hey, TCP Dumping. Good to see you. Been a lot of memes. It's pretty much taken over Twitter today. It's hilarious. I did watch the episode last night. No, this is spoiler-free zone. There's no spoilers here. That was great, though. It was really good, epic television. And I did not make it to the gym this morning because of that, because it ran over long. But I did get some study in this morning afterwards. And once I got up and got going, and I also was able to do a little bit of labbing after work, and I'm going to do some more right now. So yeah, I hope you're having a good Monday. We're of course about to hit May, unbelievably. It'll be 2020 before you know it. So trying to get some things done here. Yes, I have a little follow-up on something I talked about a little bit last week. Actually, one of my recent changes where there's been enough time passed since I applied some shaping. It's interesting. This was a case where, I have a certain speed of the link. Let's say, for example, 100 megabits per second. I'm just throwing this out here, right? You have 100 megabits per second physical link speed, and you have 100 megabits per second from the vendor, from your service provider. But even without outbound discards on the interface, I was still getting some complaints about latency, which could be a couple of things, right? One could be what's called egress blocking, right? There's two reasons to use shaping. Generally, one is, of course, if your CIR, your committed information rate, is less than your physical interface rate. That was not the case here. However, due to when there is high utilization, there were complaints about some latency. I decided to use shaping anyway and lower the shaping rate below the physical rate. And of course the committed information rate. So I'm actually taking a little bit away from the potential bandwidth with this shaping policy in this one particular case. But so far results have been good. And what I've seen is the link is definitely getting times of congestion. So shaping is taking into effect. And I'm using like 95% of the bandwidth. So I'm shaping at like 900. So 100 meg be like 95 meg. And it so far is having a good effect. So again, the two cases are egress blocking when you have downstream, you feel like you're overloading, maybe in the service provider network or somewhere else, and you just want to limit and control and hopefully improve the overall latency, reduce the overall latency or issues. So far in follow-up, I've had now some time, some distance between that change and being able to monitor it, and so far things have been going well. And sure enough, there was a customer I have, and they were looking at their utilization. Like, my max utilization is 95 meg. Boom. That's right. So anyway, that's pretty cool. Ingress on port channel, marking ingress on port channel on ISR. I have not followed up on that yet. I need to. Based on things I've got going on, I may do it today. I might play with that using just the viral image here. But I do want to play with that. I'm getting into some subtleties of the QoS config that I want to play with, and I'm kind of working my way through. It's hard to find sometimes definitive information. Like, for example, where to use a random detect command. So I've gotten some errors here and there when using it. And you want to know, for example, when you have these different tools, you have class-based weighted fair queuing or just weighted fair queuing. LLQ, and WRED, weighted random relay detection. What type of queues can you use these on? Basically, WRED is applied to one or more queues. And generally, by default, a queue will use FIFO, first in, first out. And there are certain places you can use random relay detection. So I'm kind of working through that. There was a lab. There's actually a lab here in the workbook that I'm going to move off screen here. This is the INE workbook. And this is the lab that I've been trying to get knocked out here. And I also came across this sort of confusion on my part. And that is this bandwidth percent remaining. It's funny, I've tried to use this in a few cases and it says, no, you can't do that. So short of finding some authoritative information on that, I actually just learned by experimenting. So we're going to say, for example, I've got a lab running now here that I've been playing with. In fact, let me position this over here. So where do you use remaining percent, right? And essentially use it because you've got a few ways to manage bandwidth. You can do bandwidth and a number of bits, right? We're talking about CBWFQ. We're talking about a number of bits. So bits and kilobits, megabits, gigabit. Then you can do it via bandwidth percent. And you can do bandwidth percent remaining. So which of these go together? Oh, you also have priority. So let's talk about, for example, LOQ and then CBWFQ. So here you can do priority bits and a priority percent. I'm not sure about these rules here. Mixing priority percent and bandwidth percent. We'll look at that in a second. But then you have remaining percent. And there are restrictions on when you can use this. There's actually restrictions on all of these. So it's important to know what combination you can use, right? And I'm just kind of working through these, right? I couldn't find a good chart. Like, all right, I'll just, I'll build one myself. So let me do a separate window here. File, new window. And we're going to make a little chart. So let's take this. Don't know why I just had like a little major pause there. Not sure why. All right, so priority, you would always, you generally start with that, right? Determine what is going to be your priority queue and whether that will be tracked by bits or by percent. And generally, I believe that percent is going to be favorable, a lot more flexible. You can use it in templating or across multiple routers. So let's look at our policy map here. I've got 3 classes. There's also rules around the class default. So I've got 3 classes, any, HTTP, and I kind of gave away what I was building up to here, but that's okay. We'll do class, no bandwidth. It's funny because if you mix these, even if you do no, you'll get an error on the parser. Like even if you're trying to do the no command, which would ordinarily be a regular command, take the no out, you'd apply the command and give you error. It does the same when you do no, which is interesting. And I'll show you what I mean here. Policy. All right, so let's take one of our, do show policy map. Let's take one of our classes here. And we've got class Class NA priority 5,000 kilobits per second, so 5 megabits per second. Hold on, that's, yeah, 5 megabits per second. Now, what can I mix that with? Let's do class HTTP. I'm going to make my prediction here. A little bug running across the top of my screen, like a little tiny ant. So let's say you have so I should be able to do bandwidth in number of bits. Yeah, no problem. I think with priority, I don't think it's going to let me. So you have these restrictions when you mix bits and percent. I'm not sure if that applies to LOQ and CBWFQ though. And with percent, let's try it 10. Yeah, so that's fine. And you know what I need is like a little, some columns. This is like the latest version of Excel Office 365, but it's slow on the Mac. So let's take this away, bandwidth percent 10. And now let's go back to our policy. I should have just done class policy any. Class any. I think maybe it has to use Xcode or something. I don't know. So we'll do a little chart here. We'll say we have LOQ, CBWFQ, WFQ. No, we need a different axis. So LOQ at the top, and then CBWFQ, and WFQ, and we'll do WRED. We'll also come across here. Actually, we should do this. Beach ball, not sure why. Yeah, so we'll make like one of these sort of charts. I don't know what you call these, but. All right, get some weird Windows stuff going on. I'm gonna close this out. And close that out. All right, so obviously this doesn't apply. This doesn't apply, this doesn't apply, this doesn't apply. Yeah, I get that sometimes on Discord. But we actually need, just to shorten this, I'm going to say bandwidth bits. And bandwidth percent. And bandwidth remaining percent. Yeah, that's what I want to do. And this probably varies by platform, right? But we're going to at least go with what we have. So We know that when we use, actually what we need to do here is priority bandwidth. Priority percent, yeah. All these tools are at our disposal. These do not go together. These do not go together. These work, yes. Yes. No. So, because you really, except on some platforms, you're only really going to work with one priority queue per interface. So I'm going to put NA here and NA here, right? Because of having the single queue. So if I use priority bandwidth, that's actually bits. If I use priority bits and bandwidth and bits, I know that works. Pretty sure that works. I think we already did this. So we have right now do show policy map. And we're doing a priority in bits. Class HTTP, bandwidth percent 10. Yeah. Yes. Bandwidth remaining percent. I think we're going to find that it does work here. Because the LLQ is treated differently. So I can do bandwidth percent remaining, no hyphens. Oh, remaining percent 10. Yeah, it works. You can do this. You can do this as well. No bandwidth remaining percent 10 fair Q. Oh, okay. Let's say I'm going to apply this to a physical interface. Shaping works with all of these, but the WFQ needs to know that you're using shaping. So we're going to say class. Oh, that's interesting. So what if I do class any? I will come back to that. Weighted fair queuing is a little bit of a different beast, right? So we know that WRED will not work with priority bits. It will not work in the same queue. Those are mutually exclusive. So if I do, for example, in class any, and I do random detect, yeah, you must deconfigure priority. So, but it will work in another class, or should. Random detect. Bandwidth or shape. Okay, let me put shaping on this. Show policy map. I wonder if I include it in policy map, policy parent, service policy. Oh, let's do class default, shape, average, and service policy policy underscore out. All right, let's see if it'll work now. Policy map, policy out, class HP. It's required. Do show policy map. Okay, let's put the bandwidth command on here. Class. Yeah, I don't want to shape on just that queue. I don't even know if that's a thing. But I do want to do bandwidth. Yeah. So I'm going to put yes here. Oh, no, not with LLQ. No, no, yes. And it should work with percent as well. Let's change the bandwidth. Percent 10. Do show policy map. Do show run. Well, we have it here, so bandwidth percent. We're getting a little ahead of ourselves, so let me jump back here. Priority percent and bandwidth in bits. Yes, that will work. We've demonstrated that. So let's go back though. Policy map, policy out, priority percent 10. Oh, class. And then if we go back to class HTTP, bandwidth. Yeah, so that works. Priority percent with bandwidth percent. Yes, that works. Bandwidth percent. Oh. Oh, because random detect. No random detect is on. Do show policy map. I wonder why that is. No bandwidth. All right, so there's no bandwidth configured there. Class. And then bandwidth. I thought this worked. Does. Okay. See, the parser is just really picky, man. It's no bandwidth percent 10. Very particular. It's trying to not let you break the rules, but it's not very good at communicating that. It gives that same message for pretty much any of these combinations that don't work. Now, bandwidth percent or remaining. Yeah, that will work here. Okay, so some of this is going to be redundant. Yes, yes. All right, bandwidth bits and bandwidth bits on another class works. Bandwidth bits in another class with bandwidth percent will not work. It also does not work with bandwidth remaining percent. I just happen to know that. So let's take out our class. No priority percent 10. And we'll just say bandwidth. Oh, bandwidth. All right, so it's saying mixed bandwidth types are not supported. Do show policy map. Okay, remaining percent is down here. That's why. Class HTTP. no bandwidth remaining %10. Class any. If anything else, this is good practice on your commands. Just a little exercise here. Bandwidth 5123. The Cyber Viking. I both love and hate Cisco. Love-hate relationship. I feel you, my friend. I feel you. So that works. Bandwidth bits and bandwidth bits. But bandwidth percent does not, obviously, and bandwidth remaining % obviously is not going to work. Hey, we got a new follow. Thank you, Cyber Viking, for that follow. Appreciate it. Welcome to the Land Tamer stream. Enjoy the good conversation and all the good bits we throw around here on the stream. All right, so no bandwidth remaining %10. All right, we know that does not work, that combination. Will bandwidth bits and WRED work? As far as I know, yes. So let's go to class any random detect. Yes. Yes, it does. Okay. Bandwidth %. So we'll go class any, no bandwidth, no band, no band, no hay banda. Bandwidth %10. Class HTTP. Priority bits, we already know that works. That's up here, it's redundant, right? Which is okay. Priority %, yes. We know that doesn't work. We know that works. Glad you joined, Fun Viking. Land is on fire today. Yeah, man. Hey, mentors. So you would think, this is where I got stuck earlier. You would think I can take bandwidth % in one queue and do bandwidth remaining % in another queue. Doesn't work. Doesn't like it. And it tells you please configure the bandwidth command either basically in bits. This is the same parser message, makes absolutely no sense in this case. They just didn't want to like program a better message, I don't think. Invited the peeps to join the stream, man. Thank you, mentors. Glad to have more company, as always. This really doesn't mix here. That should be a separate. Weighted fair queuing is different than class-based weighted fair queuing. They're not mutual. I think they are mutually exclusive. Yeah. Okay, but random early detection bandwidth %, yes, you should be able to do this. So we should be able to say do show policy map. Yeah, so in class, I could say I have to have the bandwidth command here, right? Bandwidth %10, random detect. Yes, no problem. As long as these work, this will work with this, right? Now, bandwidth remaining %. Yes, it does work with anything priority, whether you use bits or %. These are going to be redundant, right? Bandwidth remaining % doesn't. Whoa. Who did that? I did not do that. Bits, no. No. So bandwidth remaining % really only works with the priority queue, LOQ. From what I've found, can you use weighted random early detection? Yeah, I believe you can. So let's configure that. Class any. no bandwidth percent 10, priority percent 10, class HTTP, and then bandwidth. Oh, wait a second. Interesting. Oh, because I'm mixing it in the class. No bandwidth percent 10. No random detect. See, even though it gives me the warning, it lets me put it on there, which is very frustrating and very user unfriendly. Do show policy map. You get the feeling that folks put all this together, it was kind of, I don't know, challenging coding, I'm sure. So we're going to do, all right, what are we vetting out here? Random detect with remaining percent. So I should be able to, in this class, say bandwidth class. And why did I do that? No policy map. Policy map. Policy out. Class HTTP. And with band percent or rem percent 10, random detect. Yep, works there. So this is going to be no, no, yes, yes, yes. Redundant. So as you can see here, weighted random early detection cannot be used with the LLQ. It can be used on a queue configured for bandwidth number of bits, bandwidth percent, or bandwidth remaining percent, right? The combination of bandwidth bits and bandwidth percent, these do not go together. Bandwidth remaining percent only works when you use the priority. This also, so we can put a star here, like some notes. Bandwidth remaining percent for use with LLQ. WRED. See, bandwidth remaining percent used when a low latency queue exists. Weighted random early detection cannot be applied to an LLQ. I want to say AN because that's the acronym, but really a low latency queue. Hey, but if you have some free time, you definitely check out the latest video with Hank Preston in the toolbox. Good stuff. Okay, man. Got it. Appreciate the links. Good stuff, mentors. All right, so this all came out of a lab where it was saying it's a WRED lab, and it starts out the explanation. I've already done the lab, just kind of going through the notes here. And as it is explaining, when you apply the random detect command under a user-defined class, it automatically removes the LLQ and remaining bandwidth reservations command and enforces WRED as a drop policy. I don't think that's a true statement. Okay, we'll see. But if we do show policy map, First of all, you see here, we have WRED running, and we're using remaining percent and LLQ. So now maybe it's talking about the same queue. Let's see. So let's go to class any, and we will do random detect. Yeah, you can't. It's not going to allow you to do that. So that's the thing. I get the feeling some of these INE, the IPv6 section, the hard sections, the multicast, IPv6, and QoS are really stale, and they've not been updated in a while. Could be wrong though. And it says, let's see, when using WRED with class-based weighted for queuing, each flow is considered an individual FIFO queue. Makes absolutely no sense to me. Forgive me just a moment, I'm just reading through this here. Okay, so in the lab, we'll lab it up real quick. We're basically just dealing with router 4. So we're going to say IP access Mentors has a, right, this is iOS XE. Okay, yeah, cool, man. Appreciate it. Reading up to random detect. Okay, all right. So basically what it's saying is that each flow inside that user-defined queue is treated individually. This is like queues within a queue, sort of. Okay, yeah, this is similar to flow-based WRED. The big improvement is the ability to use random drop per flow, not per the whole queue. Now, I thought with weighted fair queuing, the explanations on here are very frustrating in this particular section of the workbook. Definitely a buffer in flow of queue, if I understand correctly. There's so little information on some of these topics, you know? Congestion avoidance config guide. This is the for the 1000V. Yeah, I call myself. I did look at this in support. Let's do it again. So if I go to support, and the menu is every change they make to the menu, it gets worse. 15.6 configuration guides. You can see I've been through here. I've been this way, not necessarily in this browser, but don't search for QoS, by the way. You got all these other acronyms, but don't search for QoS. That will be a fruitless endeavor. An intelligent way to approach it. You go into all the config guides, search for QoS or other acronyms. Oh, no. We're not going to be consistent here. Look for quality of search. Spell it out. Until I get a little frustrated with these annoying inconsistencies. Anytime I have to reference the Cisco documentation. QoS, congestion avoidance. Yeah, there was only 5. I noticed on the one you had, mentors, that there under the 1000V there were more chapters. But when you go to the iOS, there's 5 chapters. Yeah, I looked through this. Very little. We just go right into configuration. So this is called the configuration guide. There's very little guide and just a lot of configuration. There's not much guidance at all. WRED is used to adaptive traffic with TCP. WRED is usually used in the core routers of a network rather than at the edge. When a packet arrives, average queue size is calculated, right? The average is less. This is quite the useless document here. All right, let's see what we got with this blog. Thank you for sharing the link. The nitty gritty of WRED, okay. Yeah, there's quite a lot. Interface has its transmit buffer fill up, goes into tail drop state, right? It does absolutely nothing for UDP flows. Very true. Yeah, you can put it right on the interface. WRED turns any queue, be that the queuing on a physical interface or the sub-queuing on a class-based weighted fair queue, into first in, first out. The reasoning is obvious. I'm glad it's obvious to you, sir. It's not logical to apply a packet dropping algorithm to a tiered queue. Okay, if you enable WRED straight on a low speed where WFQ would be enabled by default, it will silently switch it back to a FIFO. Yes, so default outbound whole queue is 40. The minimum maximum can be tuned. Yeah, your minimum is usually what varies. Red doesn't work based on the actual queue depth. It works on the average, exactly. It's doing like statistical. One of the disadvantages of red is that it does truly randomly drop. It might drop a bunch of TCP packets with the same flow, or might target a flow that isn't taking much bandwidth. Flow-based red addresses these issues by making sort of a pseudo. Flow-based red does not work with, so we're only talking about an on the interface red. I'm so confused right now. Yep, I found that yeah, I need something else. That's not really. Let me go over to network lessons. Yeah, there's Fred too. Red. I thought I understood this when I read it in the book. And then every time I look at INE workbook, it manages to completely confuse me. I think what I may do for this section is skip the explanations in the workbook. I'll just look and see if my configuration is right. And I honestly think I need to like bypass any explanation of QoS in the INE workbook. This actually has done me anyway, more harm than good. Now I'm confused, should not go down this rabbit hole. Yeah, that's how I feel. I'll get to where I understand it, like when I read other material. And then as soon as I look in the INE workbook, like, whoa, you're doing more harm than good, INE. I mean, I like the labs, don't get me wrong. Okay, so yeah, Renee has a video. TCP dumping. Do you ever watch any of the Cisco live sessions for study material? I do. Excuse me. I did that a lot for the written exam because there's so little material, for example, on the evolving technologies. I've also used it for multicast. We may have to do this for RED because did you find a good one, TCP dumping? Let's see what you got here. I will sometimes look at the slides too, the presentation. This is a breakout session that I enrolled in. This one right here, I'm pretty sure. Return to session. Session presentation. Ah, there we go. That's one I just, yeah. I've actually watched this before. When I was preparing for the written, did not get a lot out of it, but I've come a lot farther, so. Yeah, this has some good slides in it. I don't think I watched the Melbourne one, though. I don't know if it's the same presenter. LAN Edge. Let's see if it has. Yeah, some of these slides were good. Queuing and dropping tools. things are done a little different on the switch too. So you've got class-based weighted fair queuing scheduler, transmit ring. Yep, LLQ. Up here. Okay, check out this slide, DSCP-based RED. Okay, I understand these thresholds. Fair queuing, pre-sorter, tail of queue. Yeah, I might need to watch that video. Yeah, I think they tore out the IWAN stuff because it's dying. Yeah, SD-WAN is... I did attend a IWAN presentation, though. A Cisco IWAN presentation back in the day. It was pretty good. Okay, this is cool because this actually has some good slides explaining the sub-interfaces. Front of queue, tail of queue. This is where we are. Then we need to get back to lab and studies. Already getting rusty, lose my edge. Use it for user lose it, man. So true. You know, that's the thing. Like, I'll get this one day, and if I don't use it, that's where the it's definitely where the flashcards help. I started catching up on those at lunch today. Okay, so RED needs a queue to work. This is network lessons. It doesn't work for all queuing mechanisms. Okay, so let's note this, right? So RED see, leave it to Renee Molinar to create some bullet points, easy to understand. Physical interfaces with the FIFO queue. Regular queues in CBWFQ. And ATM virtual circuit. RED is only useful. Okay, we need a flashcard for this. We're busting out the flashcards. See, I'm still way behind on these. Places where RED can be applied. Placed. Where RED can be applied, and that is physical interface or regular queue in class-based weighted fair queuing. That's what my chart says, right? And the general idea here is that what's interesting, it does not say it can be used with weighted fair queuing, though. That's what I'm curious about. WFQ. Yeah, I guess weighted fair queuing is what's throwing me off more than anything else. And he doesn't really have a lesson on weighted fair queuing. It's a really good chart in here, though. All right, well, we at least... Yeah, I'm curious, for example, the default class. Yeah, it uses weighted fair queuing by default. Here we go. uh, wow, who wrote this up? Joseph Doherty. Disclaimer, liability disclaimer. Usually I see something like this. I'm like, this is going to be not a very easy to understand explanation. Depends on what you mean. Depends on. That's probably how I would answer, though. Yeah, CBWFQ supports 64 user-defined queues. Weighted fair queuing defines up to 4,096, I believe. That doesn't really give you any information on. Yeah, I don't have to specify classes. Automatic creation based on flows. Okay, when using class-based weighted fair queuing without packets are dequeued using the FIFO method. I see. Okay. I think I get it. Nice graphs and charts. Okay, thank you, mentors. Always a big help. Okay, so I guess what I'm thinking of here is when you're referring to class-based weighted fair queuing and weighted fair queuing, you have the scheduler, right? And basically, the scheduler is pulling, it's checking these different queues and pulling packets from the queues to transmit on the transmit ring, right? And what it's saying here is that class-based weighted fair queuing, the scheduler is pulling the out of this queue. This is a FIFO queue. So they are classified, but it's just taking them in the order in which they arrived. When you use weighted fair queuing, it is not just pulling the next one out of the pipe. Where did I see that? So many windows. Okay, maybe this one had the answer. They're DQ'd based on their weight, right? So I guess we could say, how are figure 5.5 arrived, IP packet arrived, selected red profile based on weighted random early detection, random drop, yes. So that is from any of the flows. Okay. Packet arrives here. This is before it's DQ'd. Am I under the minimum for the average queue length? It gets processed, right? Am I between the minimum and the maximum? Then it's going to do a random drop. Is the queue, am I above the maximum average queue size? Tail drop. Okay. Yeah, these are our figures here. This might be a good article to read here. What, when, how? I've never seen this website before. Oh man, it's already 8:05. Folks, thanks so much for hanging out. As you can see, this is a very challenging GoFu. This is a very, I want to save this to links of the day. Thanks to you, mentors. Always appreciate it. Don't save that. And we'll save that here. Thank you very much. And I will get to reading on that hopefully in the morning after workout. We'll study time and try to understand. And great suggestion to you, TCP dumping. I may check out this. I may try to watch this again. Cisco live Rise QoS. WRED explainer. That's why I keep these agendas. So I have all these links to refer back to. But yeah, thanks so much for hanging out, folks. We'll get it. We'll keep studying until I've watched earlier versions. Okay. Yeah, I think I've watched earlier ones as well. Good bits. My man, always a great time. Stay motivated. You got it, man. Yeah. One way or another, we will figure out what happens to these packets and where they go. Thanks so much for hanging out, folks. We shall see. I hope you have a good Monday. Rest of your week. You know, let's make it a good week. Let's get a lot of stuff. Let's get her done. And appreciate all the assistance from folks in stream. Always is huge. It's like, you know, tackling it together. So really appreciate it. Hope you all have a good night. And we shall see you back here tomorrow night here on the Land Tamer stream. Good bits to all.